and I will start sharing my screen as well. My internet, so I've shifted to a new place, so my internet is not great, so I'm not able to switch on my video. So sorry about that. But okay, anyway, um, so this is the so the PPT is just sort of like a reference for us. If there's anything that we okay, this should be this course. Okay, so if there's any sort of doubt or anything that we need to demonstrate, so I can do that on the PPT. But we'll spend most of our time discussing some programming examples directly on R. Another difference that you might see in respect to the course is that in the course, most of the things are being explained to you, like almost all the things are being explained to you on the R console directly. If you remember in week 1 or week 2, R Studio was also introduced, right? So I have sort of tried to give you a flavor of R Studio from here. So I'll be showing I will be demonstrating all the commands on R Studio. It should not be very different. Uh, it's just a little more user friendly. You can see a few more things here in the environment. And also, if it's your first time working on R Studio or looking at R Studio, please let me know if there's anything you are confused about. But yep. So, and of course, please feel free to unmute yourself to ask any questions. All right.
Yeah,
Okay, perfect. So there were quite a few things covered in this week, so it's a little bit more content than what we've covered in the past. So we'll start off with the function around sequences. Now, just to reiterate, functions in R are written in the form of a word followed by the curved parenthesis, the curved brackets, or the curved braces. Last week, we also talked about how you can make your own functions, which also ultimately look like this, right? You have a word followed by the parenthesis. And any function in R would generally input one or more arguments or one or more inputs. In most cases, these have some sort of a name. So these are called named arguments. We'll also see some examples. We've seen some, we'll also see some where you may not necessarily have names of these arguments. So they're more position dependent arguments or positional arguments. All right. So the seek function to generate sequences. Um, so whenever you have to generate a sequence, it can be defined in different ways. You can talk about what the starting value is. You can talk about what the ending value is. You can talk about what's the difference between each value. So sequences give a vector as an output, and vector by itself does not need to have a trend to it, right? Vector is just a collection of numbers or a collection of characters. Sequences, on the other hand, they generally follow some sort of a pattern. Okay. So when you want to generate a vector which has a pattern, the seek function can be helpful. So a very simple example, which we had also seen in some class a few weeks back, was that you give a value, a starting value. So you call it from, you give an ending value, which is 2, and you give an increment or a decrement. Now, of course, when you start from 3 and you go to 7, it has to be an increment rather than a decrement, right? So what I'm going to do, I have my cursor on line number 4. I'm going to press Control Enter, which is what I'm going to do to execute the command. So the command from here, it gets executed in the console, right? So the console is where I get the output. So I'm running that command, and you can see the output I get. So I have 3 as my starting point. Then in increments of 0.3, it increases up until 6.9, but it doesn't go beyond that because the next value, which would be 7.2, crosses our upper limit here, right? So that's where seek function stops. If by mistake I mess up with the increment decrement, so which is the by argument here, if I give it a negative value, so I say you go from 3 to 7 in decrements of 0.3, then it's going to say that there's some error because there's a wrong sign. So R is sort of intelligent enough to understand that. So it's not going to give you a weird output that way. Okay. Now, the good part about these named arguments is you don't need to remember in which order they are supposed to come, right? So you can also jumble around if suppose you forget if it's from to by and you jumble up the order, it would still give you the same output. Okay, so these named arguments, you need to remember what the name is, but you don't need to remember what order they come in. All right. In addition to that, in addition to writing from to by, you can write two of those and write the length instead. That you want to go to 7 in increments of 3, and you want the total length of that vector to be 5. So if I run that, so here it says that you're going up to 7 and you're going in steps of 0.3 in the increasing order, and you finally have 5 outputs, right? So yeah, first output, second, third, fourth, and fifth. And again, you could have a different combination. You can write from and by and the length dot out. So that can also work. Okay. So far so good. Any questions, anybody?
No, ma'am.
All right. Okay. So now we move on to some slightly different application. This may not seem very intuitive at first, but bear with me. So here I've defined a vector. It's a random vector, right? So using the combine function, I'm just defining a vector here. And when I run this, so the good part about RStudio being that it gives you the environment, it gives you what all um, variables are there currently that it recognizes that you actually executed during this session of R. So when I'm running this, I get X here. It says it's a number vector. It has 8 elements, and these are those 8 elements. Okay. Now, even before that, maybe I'll put this here. Okay. So if I just run seek 3, can you guess what might this give us? What do you think it should return? It can be a random guess. It doesn't have to be correct. What do you think? Any ideas? Okay. If not, then
Ma'am, what's the question?
so the question is, if I execute this line number 10, if I write seek 3,
Yeah.
what do you think the output would be?
Ma'am, maybe 1, 2, 3.
Yeah, that's actually correct. All points after the third element. I'm not sure. Oh, so here I'm not using the X vector here. It's a simple seek 3, right? I'm not inputting any vector to it. So seek 3 is independent. So yes, as you rightly pointed out, it gives us 1, 2, 3. Okay. So it's basically almost as if it's saying that give me the first 3 numbers. Um, so I think mm, 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 mm. Yeah, okay, this is not working. All right. Okay, fine. So yes, so if I do not give it any named argument, it would just give us the first 3 whole numbers. The first, yeah, natural numbers for that matter, right? The first 3 positive integers. That's how it's being. So no named argument means that gives you the numbers which are possibly the indices of vectors, right? So if you remember vector indices or the positions of vectors, so this is position number 1, this is position number 2, this is 3, this is 4, 5, 6, 7, 8, and so on, right? These positions are always from 1 up till whatever the length is. So here, whenever I'm writing seek a number, it gives me those numbers, right? Now, if instead of writing just 3, So again, another example. If instead I'll just write 1, 2, 3, then it just gives me 1, 2, 3. So that is not new. But if instead, if I would just give it, let's say 3, 4, 5 also, then also it gives me 1, 2, 3. Okay. So the common aspect about these three things is when I have a single number, it still gives me as many um, values as is that number itself. And when I give it multiple values, when I give it a vector, it also gives me a vector which has as many numbers. Okay. So this is sometimes I'm not 100% sure why this might be very, very useful, but this is a functionality of the seek function. Uh, so it's mainly to give you indices that are associated with the vector, right? So this is position 1, this is position 2, this is position 3, right? So again, so this is, so what do you think line number 16 should give us based on what we just saw? So if this is X, these values, what do you think seek X should give? Uh, no. This is the hint. Okay. So what if, so let's say this was also the same answer. So it's basically you get a vector same as the length of the input vector. So what should the answer be? Yep, that's correct. Right? So so it's basically what it's telling us is whatever the input vector was, after you put that in seek, you still get, you again get a same length vector, but it's just indices this time. It's 1 to 8. It's 1 to whatever that number is. Okay. So again, I'm not very sure what sort of a functionality this offers, as opposed to directly writing 1 is to 8 or 1 is to length of X. But that is how it is. So so what this X is being assumed. So whenever I'm entering, if I'm just writing X, it's not being taken as from, or it's not considered to, it's not considered by, it's not considered length. It's instead considered something called along with. So if if you want to understand a function better, what all arguments it has, in our console, you can write a question mark followed by the name of the function. And when you press enter, here in the help menu, here like a help menu opens up. You can read a lot of information about it. So there is this along with thing, right? So this is what it does. And even if you don't write dot with, it still works the same. All right. And you can still add more arguments to it. So if I write along with this X, so that should be 1 to 8. But then I say you start from 3. So what it's going to do, it's going to start from 3, but it would still give me 8 outputs. So does this make some sense, or did I confuse you?
Yes, ma'am. Sensible it is.
Yeah. Okay. Perfect. Good. So in case any of you have any doubt, let me know. Otherwise, I will assume that it's clear. Okay. Okay. And of course, this colon symbol, that's the simplest way to make sequence if you are only interested in increments or decrements of 1, right? So if I just write 5 colon 9, that's simple. If I write 5 colon 9.5, that would only take us until 9, because 10 is going to be beyond our upper limit, right? You can also do it in decrements. So it just means that you're starting, again, it's going to be -1 from the starting point. So 9, 8, 7, 6, and so on. And of course, you can start with a decimal as well. So if I'm starting with 9.6 going up to 20, so it's going to be 9.6, 10.6, 11.6 up until 19.6. Can you tell me what this one is going to give us? What's line number 26 giving us? Just you can also just tell me the last entry that's going to be here. No need to tell the whole vector. What would 5.7 colon minus 3 give? No. So take a look at this one here. So this is why this is slightly confusing, and this is why I asked you this question. So you start off with whatever the value is, right? So here you start off with 9.6, so you actually start with 9.6. Likewise, here it's 5.7. So you do start with 5.7 and you keep subtracting 1 from it, right? So 5.7, 4.7, 3.7, 2.7, 1.7. Then you go zero point 0.7, right? Yes. So again, this is confusing. So you are subtracting 1 each time, right? So when you do zero point 0.7, after that, when you subtract 1, you go to minus zero point 0.3. And then you go minus 1.3 and then minus 2.3. Okay. So again, this question was to deliberately confuse you. So that's okay. Good attempt, but just be careful. That's perfectly okay. All right. But thank you for trying that. Okay. All right. So that's about generating sequences, right? So you have the conventional C combine function always, the colon as well, and then of course the seq, right? So these are the main three ways in which you generate vectors. And C can also be used, of course, to generate character vectors, but colon and seq are only for numeric vectors. All right. So next on, there's something about using dates in R, right? So depending on the like, so you might be just interested in getting the date or getting the time as well. We will be working with the date for today, not the time, but still this is the function. And as you would remember, R is case sensitive, and sometimes it's a little hard to remember where what's capital and what's in lowercase, but there's no easy way around it. But still try to remember that when you're doing sys date, which is short for system date, both S and D are capital and there's a dot in between. So it's sys dot date. But when you're talking about sys dot time, then T is not capital. There's no easy way to remember this. So this is just remembering. When I run this, so of course it's going to give me the date. The important part to remember here is that this is the format, that you have the year as a 4-digit number first, and then you have the month, and then you have the day or the date. And the good sort of part of using this format, why it's a preferred format a lot of places, is it's easy to use it whenever you are interested in something chronologically, right? Because let's say if I'm saving a file name using the date, if I have like, let's say 6th of September 2024 versus 6th of September, or let's say it's 2nd September versus 12th of September. So sometimes the 1 2 can come before 2, right? In some places. So it's not very easy to write it that way. So but sorry, but in this format, it will always be chronologically arranged. So 2024 and 2023 will always be separated, and then month wise it's going to be 1 to 12, and then day wise it's going to be 1 to 30 or 1 to 31. So it's easy. So anyway, this is just extra information. But long story short, the format of the date in R is this, and it's separated by these hyphens. Okay. not slashes, not forward slashes, but hyphens. So if suppose, so this is how R understands. And if I just write sys.time, then it's going to give us what the time is as per your device. Okay. Now, if suppose you have, let's say you have an Excel file where you have a lot of dates written and you want R to understand them as dates. Okay, because R can easily understand them as characters, right? Because they are a combination of numbers and symbols. So it's very easy to write them as characters. And especially when we are actually going to, since it is being written in within double quotes, so it is a character in fact. But if you want to call it a date, you'll have to explicitly mention that using the function as dot date. Okay. So I'm writing as dot date and I'm writing the date inside it. So if I had to write 30th of May, 2024, I have written it in this format, in the actual format that R understands. So if I execute this line, it just returns me that, but I know that now R is understanding this, that it's a date. Okay. Suppose instead of writing hyphens, I am interested, I'm more used to writing slashes, forward slashes. If I do that, then when I've converted it to date, R understands that it's a different format, but still converts it into these hyphens. So you see, I had input slashes, but it returned hyphens. But that's okay. It's as long as I understand and R understands, it's good. Okay. Now sometimes we do not write zeros here and there. Okay. So the thing is that of course 0, 5 and 5 mean the same thing. And of course, this is a different date altogether. This I have written it as 3rd of May, right? In my opinion, if it's 3rd of May and if I execute this, then R also understands this. So that's also fine. Right. And what if I switch it to a different format? What if I write the year and day and month in this format? If I do that, then it's going to say that it's an error. It's in it's not in the standard unambiguous format. It's a different format. So, but again, this it was able to recognize because 30 cannot be a month. But had it been something like 11th of September or something like that, where day and month can be switched, you will not recognize that, okay, something weird has happened. So, anyway, so just remember that R understands this is our default format. Okay. Very often we do not write 20, right? Because since we are in the 21st century, so it's understood that 24 stands for 2024. But if you do that in R, it does not give you an error, but it also does not give you the right output. So that's useless, right? So you just be careful that whenever you're inputting dates, it should be in this format. But now, what if um this like inputting the date in this format, in the ideal format, is not always possible, right? Because let's say again you're collecting data from somewhere or somebody else has collected the data for you and they don't follow this format, but you still want to analyze that data, right? So there are a few ways. You can explicitly tell R, okay, here is the input, convert it to a date, but this is the format that I'm using. You also explicitly mention the format so that R can convert it to the correct thing. The way this works is, so again, the first one here, line number 41, this is in a different format, right? This is not in the format R would understand. So you tell it, look, the format that I've used is this. So after comma, again in double quotes, you are writing percent capital Y. Okay. So you're saying, so this is like, bear with me for a couple of more minutes and this will be clear. So person capital Y means it's a 4-digit year slash person small d. So it means it's a 2-digit day. Then slash person month. It's a 2-digit month. So it's year, day, month. So you are saying this is the input. This is the format of the input. Now convert it to a date in your actual format. If I run this, so now you see what happened. It converted it to its own understandable format, right? It's 29th of May, 2024. So that's great, right? Is this notation clear? Hello. Is this notation clear?
Yes, ma'am.
Okay, perfect, good.
Yes, ma'am.
All right. Okay. Now, another thing that we discussed, rather than just swapping days and months, it's possible that we might miss out on writing 20, right? So then what you can do is you can say instead of person capital Y, you can write person small y. So it indicates that it's a year, but it's a 2-digit year. And then person D and then person M because it's day and then month. And when I run that, it does it in 2024. I tried looking into it, and most likely it does the current thing. So if by chance you were referring to 1924, it would not be doable. It returns you the current century, basically. Okay. So again, obviously this is very, very ambiguous, but that's the best shot we have, right? And of course, if instead of slashes you had hyphen, so here also in the format you will write that you've used a hyphen. Okay. So the output of date will always be this. Okay. When R is understanding something as a date, when you say convert it to a date, write it as a date, this is always going to be the output, irrespective of what you entered. Okay. Um, you could have also swapped something. So now any combination is okay, right? Day, month, and year, you can have all combinations. It's just that you need to write that, okay, the first thing here uh, is a day, the next one here is a month, and the next one here is a 2-digit year. So you write, okay, 12th of October, and then it converts in the same way. So it says, okay, 12th October 2024. That's perfect too. And the last thing, so it can also recognize 3-digit acronyms but all in small. So instead of writing M, you'll write person B here. I'm not very sure what B means, but B means 3-letter name of the month. So if I do that, then also I get the same answer. All right. So again, just to summarize, your input date best case would be this, but if not, then you can write whatever the format it is in, followed by you mention the format explicitly. And then when you ask R to convert it to a date, it converts it into this format, which it understands, right? So now we will try to use the format that understands. So we'll use the seek function on dates, right? So you can generate sequences of dates. Now these sequences can be a daily thing. So you can add day 1, 2, 3, or you can subtract days 1, 2, 3. You can add months, you can subtract months, you can add years, or you can subtract years. Okay. So we'll see some examples. Now, remember, whenever you write something in double quotes only, it is understood as a character. If you want to if you want something to be considered as a date, you need to write as dot date, right? So I'm going to jump on line number 48 for now. So you can see here what I'm doing here. So it says 29th of May 2023 as dot date. So this becomes your starting point, and then you say by years, and you say length is 8. Okay, so I start off with this. I increase it by years and go up till 8 years in all. So I should have 8 entries in all. So if I run this, so you can see what happens. I get in 2023, 24, 5, 6, 7, 8, so on until 2030. Yep. Now, instead, if I would have just written the date in double quotes, not writing as dot date, then R would say that there's an error, that the from argument should be a finite number. Okay. So, of course. Now, like we saw here as well, R is able to recognize slashes instead of hyphens directly. You don't need to explicitly mention anything like that. So line number 49 also gives us the same output without a problem. Would any of you like to try what line number 50 would be doing? I think you can unmute yourself and say, because typing will take a lot of time.
Yeah, ma'am. It will print a date. A date will change like 29/5,
Hmm.
then 29/6. Sorry, 35,
Yes. Yes,
and
correct.
so on. Yeah.
Perfect. Right. So yes, so 29, 30, 31, then 1st June, 2nd, so on and so forth. Up till total 8 should be there, right? So this is, these
I
are,
have just question here.
yes.
If you like a month like a 30,
Huh?
like many months end with the 30 and February end with the 28 and 29. So how we can incorporate that one?
Say that again.
Like our month is 30 and 31.
Hmm.
So here we are getting 31.
Huh?
But we need to stop 30 and then start with 1.
Okay. So since May has 31 days, so it takes
Hmm.
31 here. Now, if instead I would have written April, right? So now it's 29th of April.
Okay, it depends on like whatever we are month are putting,
Yes.
then they will take
Yes. Yes.
like
It's giving you
automatically.
actual dates. So this is
Okay.
29th of April, 30th of April, then you directly go to 1st of
Oh,
May.
understood.
Yeah.
Understood.
Okay.
Yeah.
All right. And then again, here also you are going by months. So you, if I run this, so it's 29th of May, then 29th of June, 29th of July, and so on. So you can also increase by months. Now, here comes something very, like, this is also nice functionality. You can, so obviously here it was just increments. If you want to do a decrement, you'll have to write minus. And if I write -2, it's going to subtract 2 months at a time, right? So here it is 29th of May. 2 months less than that is going to be 29th of um what, March, right? Oh, sorry, not this. This thing. Yeah, right? So 29th of May, 29th of March, 29th of Jan, 29th of November, the year before that, and so on. Right? So again, you can also work with sequences, like you can also work with sequences of dates, and again increase or decrease using days or months or years. It's just the notation is slightly more you just need to be careful. Like you have to write as dot date with a capital D. You have to write years, so it has to be like plural, right? Years, days, months. And here sorry, not this one. Like here, the example is where the date is in the actual format. But if it's in any different format, you will also have to specify that within the as dot date function itself. Okay. But the funda still remains the same. You have a date and you can have sequences from it. Okay. All right. So that brings us to, yeah, so that's one final thing from that lecture. So we have seen sequences and of vectors and all mainly for numbers. Can we even do like identify the day on that specific date? And that's a very good question. I am not sure if R can directly do that. I mean, if there is a calendar database with it. Mm, I'm not sure if it's a it can be done directly, but I'm pretty sure somebody would have. I mean, if it's a direct command, I think you'll be able to find it through Google. If not, um, I'm sure something like a calendar can also be made, because like if you have the days of, like say this week, if you have these 7 days, then you can back calculate that a given day was whatever 322 days ago. So 322 days is these many weeks and these many days. So that day is going to be whatever Monday. But to answer your question, I don't know if it can be done directly. All right. So for numbers, we have seen a lot of options, right? You can have seq, you can have colon and all. When you're working with alphabets, there are also some known vectors. So R has a lot of inbuilt databases. Okay. Um, we will work with some of them a little later when we want to talk about something like data frames and all. But one of the or two of the inbuilt vectors, if you just directly type letters here, and you can just, so in R or R Studio, whenever you type like three letters, three alphabets, it will predict what it might be that you are interested in, and it will give you that. So there are two vectors inbuilt, letters and letters, lowercase, uppercase, and it's easy to see what it could be. So letters is going to be A, B, C, D. So 26, obviously 26 length vector with lowercase alphabets. And if instead you have letters, then it's again 26 alphabets, but all uppercase. So you can directly use that, right? So if, let's say, if you want to, sometimes if you just want to find what the 13th letter is, so just like any vector, you want to specify the index. So you can have a square bracket, you put the position there, and that's it, right? So it'll give you, okay, the 13th letter in capitals is M. All right. Next up, um, there's this thing called repeats. So there are two ways in which we will be talking about repeats here. But again, so what repeats mainly means is that there is a word or there is a number that you want to write more than once. Okay. So this works with both characters and numbers. If you have something in double quotes and you write that followed by a number, that is going to get repeated as many times. And if you write a number, then that will also get repeated as many times. So again, the first argument is what you are repeating. So it's high or it's 2. And the second argument is how many times you are repeating that. Okay. So can you tell me in both cases, in line number 62 and 63, if I save these as a vector, okay, if I save both of them as vectors, what is the length of each of the vectors? First of all, is the output a vector? And if yes, what is the length of each of the vectors? Length means how
First is
many?
3 and then 4.
Yes.
Yeah, it will be vector and then the length is 3 and 4.
Perfect. Okay. I just wanted to be sure that all of you understand that we are talking about vectors, right? So whenever you have more than one number or more than one character here written in the same line, right? It just indicates that this is the first element, then the second element, third element, and so on, right? So even like in this case, first element, second element, this is the 16th element, and then this is the 17th element, and so on. Okay. All right. So if I do run this, then you can see that, as you mentioned, A has 3 elements and B has 4 elements. Okay. Now, uh, we don't even need to stop at a single um, value. We can also have vectors inside this. So you want to repeat the entire vector. Okay. So the first argument is the whole vector itself. And I say repeat the vector thrice. Now, if I do that, what's happened is it repeats the vector. So it comes apple, banana, and then apple and banana, and then apple and banana. How many characters are, no, how many elements are there in this vector in the output?
But ma'am,
Yes.
Someone is saying 6, but the value we are taking, we are repeating 3 times. So are we considering like these are the two different elements, apple and banana?
Correct. Good question. Very good question. So the thing is that we are, so vector is only sort of, so each element of the vector is a single element. Each
Yes.
element cannot be a vector in itself. So this apple and banana is not together. Apple is one element, banana is one element,
Okay.
right? So your question is very important because we will be discussing something like that a little later today. So thing is that you input a vector, you output a vector, but the original vector sort of loses its whatever grouping that is. The ordering is still there, but now apple
Yes.
and banana are no longer considered together, right?
Yes.
So, but
Okay.
that's a very important question you asked. Okay. So
Mhm.
now, yes. So the number of elements in this in the output is 6, because so just simply you started off with 2, you repeated them thrice, so you get 6. Perfect. Now there are two arguments, two types of two ways in which you can repeat something, especially when you're working with a vector. You can say that you repeat it 3 times, which is exactly what we did right now. So you take the whole vector and you repeat the vector part, like in like as together. So you don't mess with the order, right? So if when I execute line number 67, then also it gives me the same thing. But instead of times, if I write each, then what it does the repetition one by one. It repeats apple 3 times and then it repeats banana 3 times because it says each. Write each thrice. So if I execute line number 68, you see now it's a little bit different. Both of them still have the same number of elements as the output. Okay. So, uh, mm, okay, both have the same number of elements. So, based on these three outputs here, mm, these three, what does this 3 indicate? Each or times?
Um, okay.
Sorry, say that again.
No, no. I'm saying someone is saying time, but it depends on the like what we are writing. Like if we are writing 3, then first count 3,
Mm-hmm.
like 3 each, and then another 3.
Okay. So forget line 66 for now. Just focus on these two lines for now. Is the difference between them clear?
Uh,
So
yes, ma'am. Like first one is just counting 3 times. I mean, apple banana should be in a 3.
yes,
Like
apple
these
banana,
two
then apple
should
banana.
be in a three times.
Yes,
But in the second one, we are writing just a one elements in a 3 times, and the second elements in a three times.
correct, correct, absolutely. So see, overall, you are still doing the same thing. In both of these outputs, apple is also written thrice, banana is also written thrice, total, right? Which is why in both of them you have 6 elements.
Yes.
But the way in which you are writing is different. So when you say times, it means you are considering the whole thing as a group. You write the group once, then you write the group second time, and then you write the group third time. They are still two different elements, but the way in which they are appearing seems like a group. And when you are writing each, then it says each. So the first one, that's apple, that you do thrice, and then each means everything happens independently, and then banana also you do thrice. So when these two are written, that you by writing what the 3 indicates, you can specify how it should look. But if you've not written anything, what does R understand? How does R understand that what could this 3 mean?
This should be time.
Yes. So it's not very intuitive, but here looking at the 3 outputs, we can say that the default here is times. So again, this is just something you will have to remember, because if a question comes that what is the output of this one, then it just means apple, banana, apple, banana, apple, banana, 6 elements. Okay. Now let's make it more complicated. What if I have both of them? Okay. So forget this line for now. Let's just focus on line number 71. Okay. So we have two options with us. Basically, it could be apple, 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 then banana, 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 and then this gets repeated again. Okay. Or the option with us is mm, that
A,
that we could
A,
have. So times is this. So it could be apple and banana. Basically, there is just one option.
this one is correct.
Yeah, this one is correct, right? There's no other option. So let's just double check if this is the output. So yes, right? So you have this each, and then you have, so the each thing gets executed first. So this is that each thrice, and then you do that twice. So you do that again. So in total, you now have 12 elements. Now, if you remember, the order in which these come does not matter, right? Even if I would have written times first, the ordering of arguments will never create a difference. So this will also give you the same output. Okay. Again, these examples are meant to confuse you, but also clarify things. So take your time to understand these. It's not very straightforward, right? So uh, an easy way to remember it is it's sort of alphabetically. E comes first, T comes later. So first you execute the each thing, that okay, put each of them thrice, and then you repeat the whole thing once more. So of course, ordering of ordering of named arguments is not a problem. And so first each, then times, right? Okay, now comes some practice questions. Okay, not practice questions. Um, okay, I think you will be okay with even the practice questions. Now we come to one more difference, one more level of difficulty. Okay, so we already saw that if I have not written each or times, it is considered as times. Okay, now here I have a vector. So this vector is times. That's the first part you should know. 3 and 5 is not one is times, one is each. No, both of them are talking about times. But yes, both of them are times. But um, so what does this mean? That there are two elements, and you've written two times for them. So this is times, but you've written two times. So what do you think could be happening here? Any guesses?
Then first, it should be three times,
Hmm.
and then comma should be separated. Then comma. No, not comma.
Okay.
I don't know.
Okay. No, no, no.
No.
Yep.
We can write like apple, banana, up to the length of the vector C 3 to 5.
Interesting. But not the correct answer. It's not very difficult. Hint, there are two elements here and there are two elements here. Now, can any of you guess what might the output be?
Ma'am, like
Yes.
the three apple, banana,
Uh,
but we can't print like a column and row, no?
no, no.
So
Okay. What about if the 3 is for apple and 5 is for banana? What do you think that means?
three is for apple and five is for banana. Okay.
Right? So you write apple
All right.
thrice and banana 5 times. So again, so this is what I've written, that this vector is times because we saw that default is times, right? But it's individually now. So 3 times apples.
Isn't it
Right.
similar to each more than
It
times?
is, yes, that is also true. So let me not write this. You can understand it in, if that makes more sense, then perfect. Whatever is more intuitive. So that's a good point.
Ma'am, can
Yes.
we just run not 3 comma 5,
Huh.
3 colon 5?
3:5. Okay.
Yes.
Before we
I
run,
mean,
yes.
just
Sure, sure, sure.
yeah. So because like this is those both are vectors.
Huh.
This is 3 and 5,
Yes.
and also this apple and banana is also a vector.
Yes. Correct.
So
Now, I just want to mention one thing here. Apple, banana, when you're writing it in C, there are two elements. When you're writing
uh,
3:5, these are three elements, right? 3, 4,
three
and
elements. Yes, yes.
5, right? So that's a good question. And when we run this, it says it's error.
That I understand. Then to 76 will be error.
Yes, perfect. Because here it's 2 versus 3 and now it's 3 versus 2. So it gives you the same error, invalid argument, right? And here the orange is just highlighted because R understands colors. So it just understood orange as a color rather than the fruit. So that's also okay. And yeah, so line number 76 is very similar to line 75 that you just pointed out. So it's the same thing. I'll just remove it. Okay. Okay, good. So the rep function, it can be, it's very, it's a very useful function a lot of times whenever you have repetitive but some sort of a pattern data that you know it's going to repeat so many times and so on. But you have to be very careful. And these examples are definitely some of the most difficult ones. So give it a practice. Try to make some random patterns, and it should be good. It would be really worth when you're able to understand this. But I think all of you did a good job um, trying to, guess what could the outputs be. Um, one final difference in the one final modification or one another argument in the ref function is a length. Okay, so the length function, sorry, the length argument, think of it as a constraint on the length of the output. Okay, when it's a single alphabet, I mean a single element, then whether you write length or you write times or you write each, it doesn't make difference, right? In all these three cases, you get the same output. So it doesn't seem like there's any difference happening at all. However, when I do this, when I say rep apple banana length 5, I've not given it I've not given it each or times, right? So what it's going to do is it's going to repeat this apple banana apple. That's it. So it repeated. So the times thing is activated. Each is not very commonly used. So times, it keeps repeating the whole thing up until you just have 5 outputs, and then it stops. Because you said length of the output is stopped to 5. So what do you think the output of ET2 would be?
Apple, banana, apple, banana, apple,
Yes,
written four
same thing.
times.
Same thing. Ah, no. Yes. So it will be written 4 times, but it will be
Length would be
stopped.
5.
It will
Yeah.
be stopped once you have 5 outputs. So I have one more question for you. What if it was each? What would be the output then? Think about it. No need to hurry.
Apple, 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 banana.
Perfect. Absolutely. That's absolutely correct, right? So length is a constraint on the output length, but before that you can think about how it would be proceeding normally, and then you just stop once you have the requisite number of outputs. All right, great job everybody. So that completes rep. So as you can see, this is a pretty long class today. We're almost done with like 1 hour already, but I think the next bit is not as complicated. um Just one more thing about rep when you're talking about matrices. It's not very commonly used, but I think it's just worth mentioning here. So again, if you remember, when we are defining matrices, you write the data, then you write the number of columns and number of rows, and then you write whether you want to fill the rows by column or by rows. So if it's by row is true, then you fill it horizontally. If it's false, then you fill it column wise, right? The first column, then the second column, and so on. So let me just define these 3 matrices here, M, N, and P. So here again in R, you can see that these are your matrices. These are the dimensions. And another thing that you can see here is that after the dimensions of the matrix, there is a certain order in which these numbers come. So again, we've briefly discussed this in one of our previous classes, but it's just worth mentioning again. So when I wrote this one, so it's 1, 2, 3, 4, 5, 6 filled by row. So it's filled like this, right? 1 and 2 in the first row, then 3 and 4, and then 5 and 6. Now, when I want to read the elements, if I'm able to read it as a matrix, great. But if I read them as a single vector, then it is read column wise. It's just like a default reading pattern. So the way I'm going to read it is 1, 3, 5, 2, 4, 6. And that is what you can see here on the right side as well. Okay. Again, it's not very intuitive at all. And it's very confusing, but this is how it is. Likewise, for vector n, here it was filled by row. Here it was filled by column. So I filled it like this. And then again, I read it column wise. So I read it as 1, 2, 3, 4, 5, 6. And that is what this is here. And again, matrix P it's also filled column wise. So it is also read at 1, 2, 3, 4. Okay. Now I can do a rep on the matrices as well. I can do times, I can do each. It would still be considered as a vector. And this is that vector. Matrix read column wise will be the vector that will be used in the rep function. So if I say this is my matrix M, and if this is the line I want to execute. So this is matrix M. This I want to repeat it 4 times. So I have not written anything, so it means times. What would the output be?
1, 3, 5, 2, 4, 6,
Hmm.
4 times.
Perfect. And so how many elements are there in that output?
24.
24. Perfect. Okay, great. So if I run this, so yes, it is 135,246 and then 135,246, so on and so forth, 4 times. So that's 24 elements. And so to check how many elements are there directly, you can just find the length of this output. So you get 24, right? Same way you can do it for n also. So that is 1, 2, 3, 4, 5, 6. And that's done 4 times. And if this you do each, then again, I think you'll be able to tell that. So it's 1, 4 times, 2, 4 times, so on and so forth, 6, 4 times. Yes. Okay, great. So that I think finishes our rep as well. Two functions which are useful when you're talking about matrices is R bind and C bind. So R bind is when you're binding rows. And when you bind rows, so again, just this is again, you have to remember. So for R bind, binding rows one below the other. Okay. So here I want to put something below this. So a very important thing to remember is each row should have as many columns as the other rows, and each column should have as many rows. So for example, if here there are there are 2 columns. So if I put something below this, that should also have 2 columns. Correct? So now, yes. So R bind is basically you want to bind rows one below the other and it should have the same. Sorry, say that again. Any question?
No, sorry.
Okay, all right. Okay, so when I have M and N, they both have the same number of columns, right? So I can put one below the other. So if I do R bind M comma N, then you see this thing was my M and this thing was my N. But now all of this became one single new matrix. Likewise, if I want it the other way, I want N and then below it I want M, I can do it the opposite way. N comma M. Now P also has 2 columns. So I can also put P below M. So that's also fine, right? So this was M and this was P, but now everything is one new matrix. Now, can I put, so now C bind, that's intuitive if you want to put something next to each other. So left and right. So can M and N be put next to each other?
Yes.
Yes, because they have the same number of rows, right? So if I do that, so yes, it's working. So this, the left part was M and the right part was N. Can I do M comma P? So this is M, this is P.
No, row or less than. So this
Yes,
cannot be.
this cannot be. So it says error, number of rows of matrices must match. So
Ma'am, we try to create a square matrix. So then we should have Mn. Like if we see bind Mn and another matrix of column 1, how we can create a like I am just wondering. It's okay, I will do. I'm trying to create a square matrix because I need a square matrix of 123 by 123 just for the multiplication.
Okay.
So I was thinking in that way, like how we can create a square matrix of 123 into 123.
So you can do this when we are making this matrix.
Mhm.
So you know how many total elements there are going to be, right?
Yes,
123
yes.
into 123, right?
Hmm.
So you can, that number can be your 1 is to that number,
All right.
right? Okay. Yes, give it a try. You will definitely be able to do it.
Sure, sure.
Yes. Sorry, did any of you have a question?
No, no, I am saying, sure, I'll do.
Okay, yes. All right, perfect. Okay, okay. All right. Now I think we have last two things to talk about for today. It shouldn't take very long. The heavy bit is sort of over. Okay. Now we'll talk a little bit about sorting and ordering. So sorting and ordering, they're very almost synonymous words, but in R, sort and order are two very different functions. They do a similar task, but you have to be careful while using them. And sorting and ordering can work on both numbers and characters. Okay, so we'll take two examples, vectors A and B, where A is a numeric vector. I just have random numbers in it, and B is, I've taken single like alphabets for now, but you can also take like um whatever random words also for this. Okay, so anything should be okay. Now, when I write sort and I write the name of the vector, um, then it would sort them in increasing or ascending order. So increasing or ascending means the same thing, right? And that works for both numbers and characters. So if I write this, then it's going to be increasing order. So the smallest number first, followed by the larger and largest numbers. And same thing if I do um in for a character vector, then it's going to be alphabetically. But if I want it in the opposite way, if I want it in the decreasing order, then there is this argument decreasing, which by default it is false. But I can say decreasing is true. And if I do that, I get it in the opposite order, both of them. So largest to smallest and from Z to A. Fine. So this is easy, right? This is understandable. Now we do something different. Now instead we use the function order. So let's focus on this example again. For like C bind, can we do it times or each? Ah, that's a good question. Um, so you can all obviously use nested functions. You can have function within a function. What it's going to do, I'm not very sure, because once you do a times or each, like when you use the rep thing, even though you input a matrix, it now becomes a vector, right? The output of the the output of the rep function is always a vector, and you're doing a C bind or R bind on matrices. So input for C bind R bind has to be a matrix, but the output of rep is a vector. So that, in my opinion, can be a bit problematic. But I would definitely like you to try this. It would take a little long to solve that right now because I'm pretty sure it's going to give us some errors. Okay. But definitely give it a try. I'm sure you would be able to work around and identify what's happening and what's not happening. But yeah, these questions like these are really good because once you try this, you will understand a lot of things about the functions that you're using. Okay. So um it can work, but it would definitely there would be some problem in the data type itself. So you might have to re-specify the output of the rep function as a matrix and then do a C bind. So it's not going to be very straightforward. Okay. So I'm going to put the sort function in here again. So this is what the output of the simple sort function was, right? Now, can you tell me what are the indices associated with each of these outputs? So for example, here we know in the original A vector, this is index A, index 1, then index 2, 3, 4, 5, 6, 7, 8, 9. Right? So you have 9 indices, 9 positions. What is the position of -4? So that's 5. Right? So then the next number that came here was -1. So the index of that was 9. Right? After that, we had 0. So the index of that was 6. I'm just manually doing this. After that, you had 2. So the index of that was 7. Then you had 2 threes. So the index was 1 and 8. So here I'll just write 1 and 8 for now. And then you had 6 and 8 and 10. So those were 3 and 2 and 4. So these were the indices of the numbers in order, right? So if I do order A, this is what I get as my output. So when I did sort, I actually got the values in ascending order. But when I did order, I got their corresponding indices in order. Which index is first when I actually have to do in ascending order? Is this making sense?
Yes.
Okay, great. So again, same thing. Here also the default is increasing or decreasing order. And if you write decreasing is true in this case, then you get the opposite output here. And you can do the same thing with the B vector also. That's the same thing. Yeah, I mean, this was just to show you that this 5 is actually uh, uh, pointing at -4. Okay, fine. I'm not sure if this was there in this week's lecture or if it's from somewhere else, but so you have like a mean and a median function in R, but the mode function in R is not to find the mathematical mode, but it's rather to find the storage mode. Okay. So mode of A, it's numeric because it's saving numbers. Mode of B is character. Mode of M is also numbers because it's saving numbers. You know, print is a function, right? So the mode of print is function. Can you tell me what the mode of mode function is?
Also a function.
Correct. Good. Okay. So if we do have to find the mode of something, so for example, this vector A. So the mode of this is 3, right? Because 3 is appearing twice in this. That's the maximum occurrence. So there is no straightforward one-line command to find the mode, but there's a table command in R. So what it does is it gives you the frequency of each of the elements of a vector. So you can see that 3 here is appearing 2 times, whereas all the others are appearing just once. So again, it's not giving you 3 as the output directly, but through this output, you can identify that 3 is the mode. It's more like an FYI for you. Okay. I have like a just a to-do task for you. You can check the mode function by doing a question mark mode. And there are a few more. Like here, we have just talked about character, number, function, and so on. There are a few more data types or storage types which you can take a look at. We may not discuss them in this course, but it's
Ma'am,
good to have an idea. Yes.
I was just thinking about the if and else statement here.
Hmm.
Like
The mode
on
of
the
that.
second, in the table one. So like if we are printing table 1, so we are getting 1, 1, 1, 2. So can we write, can we get this number? Because if we get this number, then we can write a if and else statement. With the help of, we can get direct number 3.
Perfect. That's a very good idea. Try it. You can definitely do it, and I think that is the way to do it. That uh, you can also do like a for loop or a while loop, whichever you prefer. Because like in fact you can see you might not need that. You can There's also one more function you saw, which was the max function. Remember?
Yes, yes.
So you can also see what the max function is. So yeah, definitely, it's definitely doable. So what I wanted to mention is that it's not giving you 3, but of course you can do it. So definitely try. Sure.
Oh,
Okay. Yes. Cool. Okay. Now we come to the final bit for this week. It will be discussed in more detail in the next week again, but we'll start off with this. So this is going to. So one of you had asked about that whether that apple and banana thing, if it's still considered as a vector within a vector, something like that, when we were talking about the rep function. So vectors don't have any sort of hierarchy within them. It's just one set of single elements. But there's something called lists in R. So they are also somehow they're very similar to vectors in terms of that they are also like an order of it's a set of multiple things, but there's a lot more functionality to it. Okay. So now see, this is normally a way in which you would have defined a vector, right? In case I would write a comma b. So can you tell me what would this give me? Will it give me an error because a is number, b is character, or what would it do? Any idea what it does?
no, it will give a vector.
It will give a vector, and is it going to be a number vector? Is it going to be a character vector? Ankit, I'll come on to your question once we are done with this part, if you can wait until then. Okay.
A and B is a character.
So yes, so total will be character. Yes. So
Yeah.
A is number, B is character, but when you combine them, when you get one final vector, everything becomes character. So these numbers have lost their number quality,
Identity. Yeah.
right? Okay, fine. And you will have like what, 16 elements in this then. Fine. So this is what you do if you want to make a vector with vectors. But now if you want to make a list of these vectors, I'm calling it L1. Now you can see that here it says that it's a list of 2. So let's take a look at what L1 looks like. So I'm writing L1 here in the console. And now you can see some more complicated brackets here. You can see a double square bracket. That's this. And within that, you have the first vector. So that's this one here is about element 1, then this is element 2, then 3, 4, 5, 6, 7, 8, 9, right? That's normal. And then you have a second major element of L1. And there again, you have like what, 7 elements here, right? And each of them have retained their identity, right? This was numbers, this remained numbers. This was character, this remained characters. So now list is a group. I mean, it's a list, right? List is a list of any number of elements. So if I just write 2 out of the square brackets, then I'm talking about accessing the second major element of the list. So when I run line number 142, I just get my simple B back. Okay. And let's try something here. There is a function in R called is.identical. And what's just identical? Yeah, okay, it's identical. If I write this and B, it's going to give me true because the second element of L1, which is this vector, is actually B, right? So it is giving me the same thing. It's just like FYI for you. Again, not very important. Now, once I have accessed the second major element of L1, I can access its third element. What is that?
R.
R. Yes. Perfect. Right? Okay. Good. Now you remember we had M and N as our vectors, as our matrices. And you remember, so I'm telling you a fact. You may not need it, but still. Very often, if you use M and N as vectors, you lose their matrix property, so they become normal vectors, right? So, for example, this. If I run these, they completely lose their matrix organization, and you just read them column wise. So it's 1, 3, 5, 2, 4, 6, then 1, 2, 3, 4, 5, 6. That's it.
I have just little doubt.
Uh-huh.
Like L1, when we are listing,
Hmm.
can we list two vectors together? Like L22 and let's say L33, but 3 is what? No, I don't think so. Like L22 we
Uh-huh.
are listing, then though we are getting B.
Hmm.
But if we are listing L3, like in the double quotes, but we didn't define the 3, no?
Yes. So what would happen is, you're already going ahead with my
Okay.
example. I have it later, but it's very good. No, that's very good. So if I write 3 here, it says error, subscript out of bounds.
All right.
Right? Yep.
Okay.
Um, so yes. So you saw here, if I'm making matrices as vectors, they lose their identity. They just become simple numeric vectors. But if I write them as a list, so if I write L2 here, and if I see what L2 is, then they very much retain their identity. The first matrix and the second matrix. So again, same example here. If I write 3, there is nothing. If I write 1, I get my M back exactly in its form. And what would be the output if I write this thing? What's the fifth element of M?
4.
Yes, correct. Because you're reading it column wise. So 1, 3, 5, 2, 4. So fifth element is 4. Perfect. Okay, just two more examples. So you can have lists can be very long as well. So if I run L3 like this, so you can see here, the first element here is my vector A. The second element is vector B. Third element is matrix M. Fourth element is matrix N. And the fifth element is just number 3. That's it. So, but all of them have retained their identities. So you can access the first element, fourth element, seventh element of the first element. And okay, so what do you think this is?
2,
So my
1,
fourth,
2, 2.
yes, correct. So yes, so this is typical matrix notation, second row, first column. That's this.
Yes.
Yeah, perfect. Okay, great. Okay. Now, one more additional functionality of matrix, which sort of I've mentioned here, is that in addition to accessing matrices by their positions or the index, which you have these in the double brackets, double square brackets, you can also have names for your matrices. Sorry, names for your elements. So here, when we were defining list, we just wrote the elements one by one. But you can also have their names. So I can say vec1 is A, vec2 is B, mat1 is M, mat2 is N. So if I do that, if I write L4 here, so you see, earlier I was getting this index written before every element. Now instead of the index, I have a dollar name written everywhere. let me do one more thing here. Okay. Yes. So I have a dollar name written everywhere, but for the last one, I did not add a name. So it just gave me the position now. You see here, I had name for all of them, but for the last one, I did not write a name. So there is no name for that. It still is the fifth position, fifth element. Now, if I want to access vector 1, I can say that within the square bracket, give me 1. So that works as well, right? If I say instead of square brackets, double square brackets, if I directly write, so it's going to look like this. So L4 dollar. If I write dollar, it's able to see these things. So if I want this, I can directly access it through this name as well. So that also gives me the same thing. Another way I can write is a combination of both. So I don't write the position within the double brackets, but instead within double brackets, I have double quotes and then I write the name. That also gives me the same output. Again, all the three ways are correct. It's your choice, whichever one works for you. So for line number 163, it's important for you to remember the position. But for line 164, the name, that's a name that you have given. So most likely you would remember that name. So definitely the 164 is a preferred way. Okay. Also remember this notation that it's a like dollar something, dollar name. This will come handy when we talk something about something called data frames, but that's on there. So for now, that's the end of the session. I do have a handful of quick questions for you. They would not take very long. Oh, before that, okay. One of you had a question. Mm, 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 mm. Diagonal matrix A is this, B is this, on rep C bind. Okay. So diagonal matrix, Ankit, can you tell me what were the dimensions of your diagonal matrix? Okay. So if all of you can bear with us, let's see if I've understood this correctly. Was this the command you were using? Is this what M1 and M2 look like for you? If I do a rep C bind A comma B or M1 comma M2. Oh, I see. Oh, got it. Okay, okay. Anyway, this should not matter. Let it still be like this. Mm, 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 mm. Okay, let me anyway correct it. So M1 is just 1 and M2 is just 2. So this is what M1 and M2 are like. Yes. Okay. And then so let's say you first of all did C bind M1 comma M2. So this is what it looks like, right? C bind arranged left and right. And then you are repeating this 2 times. Okay, yes, correct. So now, now you remember what rep does is it reads the matrix as a vector. And that vector is going to be read column wise. So it's 1, 0, 0, 1, 2, 0, 0, 2. And then that is repeated another time. So that.
So like shouldn't like when you were doing for the first matrix only a single one.
Mm-hmm. This one?
Yes, yes.
Yeah. So I also got this.
So I'm saying like it was giving like the whole row first, then the second row,
No,
like
no, no.
whole matrix,
It was
then the
not
whole
doing that.
thing.
See, it was doing the first column, then the next column. Right? You see? It's column and then column. You also got that.
Oh, okay,
And
okay.
column, column, column. Right? So yes, so this is very important. Just remember that if a matrix is to be read as a vector, it is read column wise. Okay. All right. Okay. So let's go to some quick practice questions. I think this would be very easy for you now, right? You've done a lot of practice, so I'm not writing the output. You also don't need to tell me. I think you've understood what each and times does, right? So this is you can always try this, but I think you're all good to go. Okay, what is this then? This is important. So first of all, yeah, I mean there's two ways to do this. Let me just get my pen here. So would any of you like to try?
I think 5, 4. -5, -4. And this,
So you remember when we had two vectors given in this? One
yeah,
vector
and
was the input and the other one was how many times each element has to be repeated,
yeah. So
right?
this length is 8.
So
And
-5 would be repeated two times,
Okay.
-4 three times,
Okay. Now,
and like
yes. So now you see the length of the two things is not the same. So it would give an error. Hmm. Again, this is just to confuse you. Ah. So the correct question is this. So you know how to do this, right? So it will be -5, -5, -4, -4, -4, so on and so forth until 2, 2, 2, 2, 2, 9 times, right? Okay, good. You know this. Um, hmm. All right. So this is a question that has almost everything that we covered today. It has rep, seek, and list. So let's try to make that list. I think this is, yeah, it's just one more question after this. Okay. So can you guide me on what each of the elements here are? What's the first element of the list?
hi.
Hmm. Okay. So, and I've also sort of named it as X1, right? Okay.
1, 2, 3. Okay.
And the second element is also this thing. So it's in double quotes, so you don't solve this. We are calling it X2. And then the third element, which we are calling it as X3. Now that's a little bit complicated. So we are saying that go up till 2 and the total length has to be 3. So we are always going in increments. The default is increments of 1. So what would be the other elements of this vector? That's C.
0, 1, and 2.
Perfect. Okay, great. So this does it. And then we say rep twice. So what's the output vector going to be?
0, 1, and 2, 0, 1, and 2.
Perfect. Great. Okay. Okay. So that's it, right? So these are our list elements, the elements of Z. So what's the correct output of this?
0, 1, and
0,
2.
and 2, 0, and 2.
Good. Okay. What's the correct output of this?
3 minus 5 plus 9.
Yes. Okay. What's the correct output of this?
7.
There's a missing bracket here.
Okay. So this becomes
So there should have been like this, right? Then it would have
um,
been correct. All right.
all right. Yeah.
So that's, yeah. So just one last question. If you want to generate a sequence of 3 yearly dates, so 1st of July 2020, 1st of July 2021, and 1st of July 2022, which command would you use? So using the seek function, right? So generally in seek, you're doing a from to by sort of a thing.
B.
No, not B.
A.
Then yes.
Yes, it's A. Okay.
And what is the error with the B? And it
So B has a lot, it has 3 arguments. 1, 2, and
and
3.
this is a by ear.
And D is also not capital, right?
Okay.
And here A has to be small. And this is weird, right? So A is the correct output. Okay. If you have any questions from previous assignment, we can discuss that. But if not, then it was definitely a very long class today. So I won't keep you any for any longer. I hope this session clarified a lot of things from this week, and it'll simplify, it'll just ease things for you to solve the assignment for this week. Again, if you have any questions, please post it on the discussion forum. Somebody will hit to it, help you out for that. But I think all of you have done a good job today and very interactive. I really enjoyed the class. Thank you for joining. I will see you all again next week. So that's 13th of September.
Thank you.
All right. Thank you so much. Bye-bye, everybody. Good night.